Hello, and thank you for joining me in another of our series of quick videos showcasing the art of the possible with the Elastic Stack. My name is John Knepfle, and I'm a solutions architect here at Elastic. In this episode, we'll be taking a look at several new features that continue to expand our growing observability story. Specifically, I'm going to show you how the new distributed tracing capability in Elastic APM, our new infrastructure solution, and our log solution can be combined with things like machine learning to make it much easier to manage and diagnose issues with complex distributed applications running on large-scale infrastructures. For this demo, I'll be running this pet clinic application deployed in a Kubernetes cluster running on 3 large 64-core nodes. The application consists of an Nginx React Node.js frontend, Java Spring and MySQL for application logic, and Python with an Elasticsearch backend for the address lookup service. To monitor everything, we've instrumented the application services with our APM agents for React, Node, Python, and Java, and we're using FileBeat, PacketBeat, and MetricBeat deployed as Kubernetes daemon set to collect logs and metrics from each of the application service pods. With Beats Auto Discovery, monitoring new pods as Kubernetes scales the application services is handled automatically for us. In this scenario, we've received an alert that our pet clinic website is experiencing a general widespread performance issue. So unfortunately, our customers are probably seeing a lot of this. With the old way of doing things, we'd probably start investigating this issue by rounding up everyone involved with the application, huddling in a room together, and start looking at a variety of different tools like these to figure out what's happening. Fortunately, we're using the Elastic Stack, and we have an advantage. Here you can see that we've used Elastic Machine Learning to look for anomalies in our pet clinic application's logs, metrics, and traces. We can see that, indeed, it does look like there is an issue. We see some recurring anomalies. Let's take a closer look at one. Each anomaly links us directly to other tools in the Elastic Stack that will hopefully lead us to insights on what might be causing the problem. We'll start by taking a look at the APM tracing for our application. Here's a look at the new APM distributed trace feature. You can see that we have traces spanning multiple services in our application, regardless of the underlying technology or language that was used by the team that developed the service. For example, for this transaction, we see traces for 3 services, color-coded by service, using React, Node, and Spring. If we take a look at both a fast transaction like this one, or a slow transaction like this one, both traces look similar, so there's no smoking gun here. Let's go back to the same machine learning anomaly we looked at before and take a look at our service analysis dashboard. Here we again see recurring performance spikes. Let's focus on one of them. As we scroll down this dashboard, we can see that this heat map clearly shows that most services are being affected. With that in mind, let's zoom out and take a broader view. I'll go back to our machine learning anomaly that we started with and open up our new infrastructure view. Here we can see the entire application landscape at a glance. We can look at our hosts, at Kubernetes, or at our Docker containers. I've opened up the Kubernetes view and we can immediately see that one pod jumps out and appears to be consuming more CPU cycles than any of the other pods. That's interesting. Switching to the container perspective, we see that one container is again jumping out. It looks like MySQL may be the cause. Let's take a closer look at that. I've drilled down into the metrics for this container, and we can see that there appears to be a recurring spike of CPU usage by MySQL. Next, we'll look at the dashboard we set up for MySQL. Let's zoom in on one of these spikes. When we do that, we can see in our top processes visualization that the most prominent CPU consumer is the DB backup process. Anyone that has debugged problems like this knows that sooner or later you'll want to log into the server and tail the actual log file. That's where our new log solution comes in. Now I can tail the suspected MySQL log file right from Kibana without having to figure out where Kubernetes has deployed this particular MySQL container. Since everything is in an Elasticsearch index, I can easily look for slow MySQL queries without having to resort to tools like grep. Sure enough, it looks like the DB backup process is doing a query that causes a high number of rows to be examined on a recurring basis. It is almost certainly the culprit impacting the performance of the database and in turn the entire pet clinic application. So what do we see? I showed you how we can bring together logging, metrics, and tracing in Elasticsearch, and then use machine learning to automate the detection of anomalies in the performance of our website. Then, by providing a variety of UIs, such as our infrastructure view and our logs view, as well as APM tracing and custom dashboards, we can observe a complex application and infrastructure at a very broad view, but still be able to drill down into the details as needed, all without ever having to leave the comfort of Kibana. Thanks for watching.